The next example. We are given this function, the quadratic function 3x squared minus 6x plus 1. And in this example, as well as the next one, or the next two, we need to do two things. First, we need to write the standard form of f of x. So write f of x in a standard form. And then, part B, we need to sketch the graph of f of x. And we prefer to do it without the use of the graphing calculator. Okay, so let's solve the problem. We start with the function itself, f of x, and we'll go through the steps. We'll use the method of completing the square. Okay, so let's write the function 3x squared minus 6x plus 1. The first step we want to do, here we can do it in two different ways. We need to factor 3. And now, in the morning, and last time I factored 3 from the whole trinomial. This is called normalize the function. In other words, get the factor 3 so that the coefficient of the leading term, x squared, will be 1, positive 1. So if it was like negative 3, I'll factor out negative 3. But today, I'm going to factor, I think it will be simple or simpler if I'll factor 3 only from the two terms contained in x and leave that one alone. So if I do so, I have 3 x squared minus 2x, and then plus 1. So notice that 3 multiply only the terms in the parentheses, but doesn't multiply 1. Now I need to complete the square. So how shall I do so? Well, to complete the square, x squared minus 2x plus 1 is a trinomial that is a perfect square binomial, is x squared minus 1. And the way to find your h, basically what we are trying to do, we're trying to get to x minus h squared. Okay? H will be 1/2 of the coefficient that multiply x. In our case, I can write it as x minus 2x, x squared minus 2x, and I'll add 1 to have a perfect square trinomial. Okay? Now, that one in red, we did not have it to begin with. So, to make up for it, I need to subtract how much? 3, because it's 3 times 1. So we need to subtract 3 and add the 1. Okay, this is the process of completing the square. Now, here's what I've accomplished. This trinomial is x minus 1 squared, and what I have left here is minus 2. And that's it. That's the result. So in general, this will be equals to a times x minus h squared plus k. H always going to be 1/2 of the factor of x. Okay, go ahead. Exactly. That's why I put it in red, and that's why I subtract negative 3. So, because I have only 2 terms of the 3 terms that are in the trinomial. Okay, a perfect square binomial, or a square of a binomial, is a perfect square trinomial. We call it a perfect square because we can write it as a square of something. In this case, the square of x minus 1, if you clear the parentheses, you make it a trinomial x squared minus 2x plus 1. The negative 3, because you actually add not 1, but 3 times 1, because it's inside the parentheses, and you have the 3. You see, that what I did last time, I factor everything, and 3 was multiplying everything, and I had to add 1, but then here I had 1/3. It doesn't matter what I did last time. I tell you, I think this will be a little bit easier to absorb. Okay, just you need to remember that you only factor 3, the leading coefficient, the coefficient of x squared, only from the terms containing x. You don't factor it from the free coefficient. Does it make sense? Okay, so this is the result, and what we see from here that we have a vertex, we're going to need it, the vertex hk equals 1 and a negative 2. Okay, go ahead. The negative 3. Okay. How much did I add to the original equation up to this point? I added the 1 in red, right? But the 1 in red is multiplied by 3. I did not have it before. I had only the 1. So I need to subtract with the amount I added to the equation. All right, let's do part B. Let's write the result. The result was, we started with f of x equal 3x squared minus 6x plus 1, and we say that after completing the square, we have 3 times x minus 1 squared plus 2. Minus 2 or plus 2? Minus 2. So, when we sketch this graph, we're going to start with the vertex. We know that the vertex is 1. So let's write hk equals 1 and negative 2. And the coefficient of the leading term is positive 3. So we know that the parabola is going to be facing up, but it's going to be stretched, vertically stretched. So it will be long and narrow. Okay? So we do have the vertex, which is right here at 1 and negative 2. We know that it opens up. I'd like to know what is the y-intercept. The y-intercept is the value of y when x equals 0. Okay, so the y-intercept will be f of 0. I can look at the top, and I can look at the bottom. If I look at the top, 0 minus 0 plus 1 equals 1. If I look at the bottom, 3 times 1 minus 2 equals 1. So when x equals 0, y equals 1. Okay? So because of the symmetry, then we can get, because the axis of symmetry is x equals 1, this is the axis of symmetry. The vertex always sit on the axis of symmetry. Since the y-intercept, 0 and 1, is 1 unit to the left of the axis of symmetry, then I know that y equals 1 unit to the right. So another point will be 2 and 1. So knowing the y-intercept can give you additional point, and that will be enough to sketch a fairly accurate graph of the parabola. Okay, the vertex tells us what is the horizontal and what is the vertical shift of y equal x squared, and A3 tells us whether it face up, face down, whether we need to reflect it or not, and whether we need to vertically stretch it or compress. Okay? Make sense? I'm sorry? You tell me. So you ask and you answer your own question correctly. Yes. One thing you want to make sure that when you say stretch or compress, you need to specify whether you do it horizontally or vertically, because people cannot get into your head and realize, we know what you mean because we see the graph, but imagine you're talking to somebody in Timbuktu and you tell him, oh, well, we stretch or compress. You need to be very more specific. You need to say we vertically stretch or we horizontally stretch.